Hi everyone, welcome to week 3. Welcome back, great to have you. Anyone new joining, my name is Mr. Gill. Welcome. For anyone who wants to get hold of our previous lectures, our website is on the bottom, www.inspired-learning.org. You can go on there and we've got our 2 previous lectures as well as all the resources that we've used so far as well, including the lesson slides that you can see in front of you today. We're going to be looking at binomial expansion today. Hi Josh, welcome back, great to have you. Say hi in the chat as well. Hi Healy, welcome back, great to have you as well. We're going to go to binomial expansion today. It's not as big a topic as the ones we've done, so today may be a bit shorter, but we've got plenty to work through anyway. And we're going to touch a little bit onto the statistics side of things as well, just looking at binomial probability as well. Okay, so let's get going. As always, the plan for today, we're going to go through some basic rules of the topics we're learning and then look at the applications of it as well. And then if you've got any questions, if you're not sure, go to the live chat, email us or get in touch with us on text or WhatsApp. Our phone number's up there and also is in the description. If you're going too fast, you want some more time, pause the video if need be. There's more problems, there's a worksheet in the description, and as always, any feedback is greatly appreciated and welcome. So this is what I've broken down binomial expansion into as a topic. I'm gonna close my video. You don't see me anymore. Okay, so we're gonna break it down. Look at each of these things. We'll probably do the first 3, have a short break, and then go on to the last 2 there. But we'll see how we go. So first thing we want to understand is just understanding what Pascal's triangle is and how it comes about and how it's repeated. So hopefully you are all familiar with some basic rules. The most basic one being that we get a number below by adding 2 above. What I mean by that is, for example, we get 1 plus 1, which will give us the 2 here. And then we'll get the 2 plus 1, which will give us a 3. 2 plus 1, which will give us a 3 here. Then we get 3 plus 3, which will give us the 6. 3 plus 1, which will give us the 4. And again, 3 plus 1 here, which gives us 4 here again. So it just carries on, right? And that's how we go down Pascal's triangles and we go about getting these numbers. What we also have is you'll see some patterns that go diagonally. So you can see here we've got 1, 1, 1 repeating itself. Then we're going up in 1's going 1, 2, 3, 4, 5. And then here we've got another pattern going up first in 2, then in 3, then in 4. So we've got triangular numbers here. And this notion repeats itself if you were to keep going on as well. Okay, so there's loads of patterns within Pascal's triangle. You don't need to know the pattern specifically, but they are just helpful. They are helpful to know. The one you do need to know is how we go down the triangle. So the orange and blue highlighting I've done there, just to show you how we get those new numbers. Okay. So this should actually be quite familiar, nothing new. We can then use this triangle to expand brackets like this. Specifically binomial. Binomial meaning a bracket with 2 terms. Bi meaning 2. So the 2 examples you see on the screen now, they are binomial expressions because there are 2 terms within those expressions that we then expand. And the numbers, the values from Pascal's triangle give us the coefficients of each term in the expansion. What I mean by that is this first one, so we've got, this is to the power of 5. So if we go here, if we look at the triangle, I'm just going to try and move this across a little bit. So if we move this across, our triangle, the coefficients for our triangle will come from 1, 5, 10, 10, 5, 1. So what this means is we'll have, this will go to, this equals 1 times something. We're going to come on to the other bits in the middle. We're just going to focus on the coefficients for now. But we're going to come on to the individual terms as well. 1 times something plus 5 times something plus 10 times something plus 10 times something plus 5 times something plus 1 times something. Now the key bit is understanding what goes in the something, right? Coefficients have to be a coefficient of something, otherwise they're just numbers, right? They're just constants. And the way we look at this is we look at what's in our brackets here. Generally we take the first term in the bracket and have that descending in power, and take the second term and have that ascending in power. What I mean by that is this. So the first term, the coefficient is 1, then it's going to be a to the power of 5 and b to the power of 0. And then we're going to move along, just increasing and decreasing respectively. So the next one would be a to the 4, b to the 1, a to the 3, b to the 2, a to the 2, b to the 3, a to the 1, b to the 4, and lastly a to the 0, b to the 5. Now from lecture 1 2 weeks ago, we looked at and understood what powers mean and properties of certain powers. So we should understand that anything to the power of 0 is 1. So I can just cross through these. Anything to the power of 1 is just itself. So I can cross out these indices here. And then we can write this neatly below. Well, 1 times anything is just a thing, so I'm not going to include the 1 first. We should get a to the 5 plus 5a to the 4 plus 10a cubed, 10a to the 5a to the 4b here, my apologies. 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4, and lastly plus b to the 5. Okay, so here I've just used two algebraic terms, a and b, and done it like that. The expansion, the second expansion here, that expand 3 minus x to the 4, we can do exactly the same way. So let's do that. I'm going to give you some time to go through and have a go at doing that. Just very, very quickly there. Okay, so I'll give you a couple minutes, go through, expand that, and then I'll go through the answers for that in just a moment. So use Pascal's triangle here. Think about what we need. 3 bits for each term in the expansion. We need our coefficient, our first term to a power, and our second term to a power. Okay. So our first term to a power, second term to a power. So we should have first bit 1, 3 to the power of 4, x to the 0, plus 4, 3 times 3 to the power of 3, x to the 1, plus 6 times 3 squared, plus x also squared, plus 6 times 3 to the 1, x cubed, beg your pardon, plus, should be plus 4x, 4 times 3, there we go, 4 times 3 to the power of 1, x to the power of 3, and lastly 1 times 3 to the power of 0, x to the power of 4. So what we finally end up with then, simplifying all this together, we're going to have 3 to the power of 4, which we're just going to write as a value. So this is going to be 81 plus 3 cubed is going to give us 27. Multiply 3 by 4. We want to simplify this. 108x plus 54x squared plus 12x cubed plus x to the 4. Okay. So this is very basic. This is very basic. This I'm just going to circle this. This pattern here is how we find any term in a binomial expansion. With a coefficient, we need the first term to a power and the second term to a power. And we're going to look at some of the patterns that occur here just in a bit later on. But you can see we can use and get the coefficients from Pascal's triangle. And this is quite straightforward when we're dealing with very small indices, even up to sort of 5 or maybe even 6 or 7. But once you start getting past that, it becomes very complex to first derive the triangle and then use it. So instead what we do is use this formula on the right here. Okay, n factorial, this exclamation mark here means factorial. And all that means is that number multiplied by everything that's come before it up to 1. So for example, 6 factorial would be 6 times 5 times 4 blah blah times 1. Okay? So this is how we start off. Any value here, any value, we use this formula. We use this formula to find any value in here. And what we do is we say R, N is what row it is, and R is the position within that row. So for example, if you wanted to find this value here, this would be N equals 5. So N equals 5 and R equals 3. So to find this 10, we would do 5 factorial over 3 factorial times 5 minus 3 factorial. Just like that, okay? This is given to you in your formula sheet as well, but we need to understand how to use it. Okay? This is the notation that's given to you in your formula. This language we use to describe this is called N choose R, right here, N choose R. And on your calculators, you should see this button. For most of you, it will be above the divide symbol. For some of you, if you've got those graphical calculators, you have to use some different settings. It will be listed under probability in your run matrix. But this is the general formula. And then this is just plugging numbers in and finding them. So all we do in our calculator, for example, to find this one, we're going to do, that's a terrible arrow, 14, and then press NCR 3, and then hit equals. Okay? So just make sure we're fluent with that. Go through and grab these values, and I'm going to write up the answers in just a second. So first one, we should get 364. This one, we should get 6. And this one is not possible. And this is because we want to be really clear about something. If we go back to Pascal's triangle and we look at the 4th row, right? So we had 4 choose 5. We have the 4th row, and there are, we can see 5 values here. 1, 4, 6, 4, 1. So why is it then when we do 4 choose 5, we don't get this value? We don't get the 5th value. This is the 5th position within the 4th row. So it should work. So the question now is, why doesn't it? The reason it doesn't is because we always start from the 0th position. So the first value in any row of the Pascal's triangle is 0. Absolutely spot on, Healy. Yeah, absolutely spot on. So this would be, for example, in this situation, we would have 4 choose 0 up to 4 choose 4. So that the bottom part of our choose function can never be greater than the top part. Okay, the bottom part of our choose function can never be greater than the top part, even though there are 5 positions within, or more than one more position than the number of rows. So in the 4th row, there's 5 positions. In the 5th row, there's 6 positions. In the 20th row, there'll be 21 positions, and so on and so on. So we just have to make sure we're aware of that, okay? All of that then leads to this, which is, again, in your formula sheet, and you should definitely be familiar with it. Or make sure you get familiar with it. And the key things to understand about this is it does not matter too much about what this number here is, but what matters, this number that I've highlighted there. So it doesn't matter what number that is, as long as it relates to your indices. Because of the symmetrical nature of Pascal's triangle, this number needs to match one of these indices here. Now, let me just change these highlighting colors. So for here, you can see that these indices match the highlighted indices, but actually, let me choose a different one. So we've got, and then I've got some blue highlightings there, right? So that bottom part of the choose function must match either the power of A or the power of B. As long as that happens, the key thing then is to understand that the powers of A and B must add to give you the top of the choose function. Okay? So whenever you're figuring out, and this is really helpful when figuring out individual terms, but whenever you're expanding a binomial function, this is the key thing to bear in mind. Does the bottom of my choose function match one of the powers that I've taken my raised my term to, and does my top of the choose function, is that the sum of the two powers that I've got there? Okay, the two powers that I've got there. That's the key things to bear in mind. Okay, so let's have a look at some of these questions now, and understanding this makes it a lot easier. Whenever, like we said, whenever we're expanding, I'm just going to draw this box over here. Whenever we're expanding any binomial expression, we always want to set it up. I would even draw these three boxes out so you know what you need to expand. Okay? So you know what you need to expand. So here now we've got the first bit, which is going to be the choose term. The second bit, which is going to be our first term to the power. And the third bit, which is going to be our second term to the power. And it's really crucial. You will have noticed here that when I've drawn my box around my second term, this negative is included. It's really important to make sure you include that negative and expand it correctly. So this first one, we're going to get, this is going to be, I'm not going to do the coefficient for the first one because it's just 1. It's going to be 4 to the power of 6 plus 6 choose 1, 4 to the 5, and then minus 2x to the 1. So it's really crucial that we include that minus. Then when we go through and multiply it out, we have to make sure we're taking account of the minus. Plus 6 choose 2, 4 to the 4, and then minus 2x squared. And we only want the first 4 terms, so just one more, plus 6 choose 3, 4 to the 3, minus 2x cubed. So we're going to get, in fact, what I would do is I would make a note above it when I'm expanding this and say, well, this is going to be negative, this is going to be positive, this is going to be negative, because any negative number to an odd power will say negative. Any negative number to an even power, like the term we have here, will become positive. And then it's just a matter of putting these values into your calculator and simplifying to get your answer. So we should get the first one, 4096 plus this is going to be, my apologies, minus some big numbers, 12,288x. This is going to be plus. So we've got 6 choose 2 times 4 to the 4 times 2 squared. So this is going to be 15,360 x squared. And then last term plus 6 choose 3 this time times negative 8. So this is going to be minus 10,240 x cubed plus dot dot dot. Right, we know there's more terms in here, but we're just not interested in them. Okay, so plus dot dot dot. So that is our final answer in its most simplified form. Always recommend always write out the unsimplified version before going on to the simplified version. Okay, so once you've got that example done, have a go at doing the example on the right hand side, paying very, very special attention to the fact that this is a fraction here. Okay, so when you expand it, make sure you account, just like we accounted for the negative on the left hand side, Make sure you account for this fraction here. Write it out using this free format. Like we're using these boxes if need be as well. Again, we just want the first 4 terms, just for the first 4 terms. My apologies. In this no, sorry, ignore that. I'm confusing myself. Ignore that. Carry on with the question on the right hand side. I'm going to get some massive numbers for this one, just so you're aware. So I'm going to start writing out the answer for this right hand side question. I'm just going to do it at the bottom of the screen here, just to give myself some space. So our first term, massive number, okay, 1679616 plus and then we're going to get 54432 x squared, and then the last term sorry, that coefficient for that third term there is incorrect. We should get 326592 x squared plus, now the final term, 54432 x cubed. Okay, so a massive expansion there. Different number for the second term. For this 12288, so let's just go back and double check. So we should have, this should be 6 choose 1, which is going to be 6, times 4 to the power of 5, multiplied by 2. I think here 12288 is correct, so we should have 6 choose 1, multiplied by 4 to the power of 5, multiplied by negative 2. So just double check that, but I think that one is correct. And then this is at the bottom, the answer for question 2 down there as well. So just double check those answers there. I'll give you a second just to go back and check anything you need to. There's only a few of us here, so I'm obviously more than happy to adjust and slow the lesson down. So don't worry about asking questions. Like, absolutely, it's key that you understand what we're going through. No worries, Healy, no worries, no worries. It happens to the best of us. Okay, so Again, also if you miss anything, these lectures will remain on YouTube. You can get the slides as well from our website. I'll send out an email afterwards, as always, with all that information too. But yeah, so don't worry, if you miss anything, don't worry. You can go back at a later time, and all this information will be timestamped as well. Okay. So, and this is really important. People will regularly make mistakes in a number of areas. The first one will be negatives. Right? People will miss out the negative, which is why I've included this question. The second one will be fractions, and people will sometimes miss them out, or sometimes put them as coefficients of, so rather than x over 2, they'll put 2 over x and do it as an integer multiplier instead. But the last one is probably the most common one. And what people do is when they expand, so for example, if we go back and take the final term in this expansion, when they go back and expand, so we had 6 choose 3, 4 to the 3, and then minus 2x also to the 3. And what they forget to do is take the power and apply it to the coefficient of x. And this is a really, really common mistake. So people will do the 6 choose 3, they'll do the 4 cubed, they'll end up with x cubed, but they miss out raising the coefficient of x or whatever our algebraic term is, and raising that to the power as well. Okay, so there's just something to be really aware of and mindful of. Okay, so negatives, fractions, and the coefficients of your algebraic terms as well. Okay, and you'll see there's an exam question here. Very, very similar to the types of questions that we've just done. So I won't spend time going through this, but I just wanted to sort of let you see, they make the comparison of actually in terms of this specific thing. This is very similar to, the wording might change a little bit. For example, they've put ascending powers of x and giving each term its simplest form. But the principle is the same, right? They want you to find a certain number of terms of an expansion and to use the method that we've just gone through. Okay? So, next thing is about finding and looking at individual terms. Okay, I'm just going to block that question out for a second. So looking at individual terms. So it says give the coefficient of x to the power of 8 / the 9th term in the expansion of a plus x to the power of 10 in ascending powers of x. This bit is really important. So I made this question in an exam or in textbooks or anything you're working through. You will not see it written as x to the power of 8 / the 9th term. But what I wanted to clarify and point out is that the power in general, when you're doing ascending powers of x in a question like this, the power of x is not the same as the number of the term. And this is where they try to catch people out, and this is where this question is really designed to get to test your understanding of binomial expansion. So the 10th term would be x to the power of 9. The 5th term would be x to the power of 4. So it's about understanding the relationship between what term we are dealing with and what power of x we are dealing with. And this goes back to what we talked about earlier about starting at Pascal's triangle with a 0th term. Okay, but our principle is still the same. We still want to start off by having these 3 boxes. We know we're going to have in the first box some kind of choose function, 10 choose something. I wouldn't even worry about what we have to make it choose just yet. I'm just going to write it as 10 choose something. Then, second bit, we're going to have a to the power of something. And then x to the power of 8 is given to us in the question. Now is when we use our understanding of how binomial expansion works. We know that the powers of our 2 terms must add to give us 10. We've already got 8, therefore a must be to the power of 2. Then we know that our choose function must match either index of our terms, and normally we take the first one, normally we take the second one, so this is 10 choose 8. But like I said, 10 choose 8 and 10 choose 2 will give you the exact same value because this is symmetrical, because Pascal's triangle is symmetrical. So then it's just a matter of finding out what these terms are, and we're going to end up with 45a squared x to the 8. Okay? So I would always lay it out like that. Have the 3 boxes, use the information given to you in the question, and then go back and fill them in. Okay, and then you can see, I might need to scroll across a little, so you can see here an exam question. Again, very, very similar wording. They've obviously used x to the 4, and they haven't given you the hint that I gave about it being what term it is. About what term it is. But again, have a go at answering that, and I'll give you about half a minute to have a go at answering that, and then I will write up the answer in just a second. Remember, we want to simplify this as much as possible because now we've got numerical terms rather than algebraic, so we want to make sure that those things are simplified. Okay, so about another 15-20 seconds or so. I'll just start filling in some working here. Okay, so here then we've got that this will expand to give us, we've got a negative term here raised to a positive power, so we don't need to worry about this negative. We will end up with 6,000 x to the power of 4. 6,000 x to the power of 4. So we don't need to worry about the negative, but the 2 is still raised to that power of 4, which we do need to account for. And then we get our answer 6,000 x to the 4. So I've just got this table here. Let's have a go at just filling in what this is. And careful, what I'm trying to clarify here is I'm not asking for the expansion. All I want you to do is, so this is the power of x we want is 3. What term, which number of the term will this be in the expansion? Going back, so just a reminder that when we had x to the 8, it was think about what term we had in the last question. And then just go through, I'll give you about half a minute to go through and just fill that in. Okay, so this first one is going to be the 4th term. Second one, 51st, and then hopefully you can start to see a pattern here. We're going to have 8th and then 4th term. Right, so just I beg your pardon, I've fallen for my own trap here. So let's go back and have a look at these again. For question 1, it is going to be the 4th term. But for question 2, assuming we're still going in ascending powers of the 2nd term in our expansion, so assume we're still going ascending powers in 2nd term of our expansion, the 2nd one, if we want the 50th, the power of x to be to the 50, well, we're starting with x to the 75, which means this was going to be the 25th term. Because in here, as I said in general, we take ascending powers of the 2nd term in our expansion. So because we're starting with x to the power of 75, it's going to take us 25 terms, or the 25th term will be where we get to x to the power of 50. sorry, this is going to be the 26th term. 26th term. Because we're starting with the first term, which will be 75. So 26th term. By the same logic, then, if we want, at the bottom we want power of x cubed. So we're trying to find x cubed. We're going to get the 14th term, right? The 14th term. Again, a reminder, this is because we start at 0. So the first term, for the bottom side, the first term would be x to the 16. Second term would be x to the 15. Third term would be x to the 14. So each time, the number that we're taking away from the power is 1 less than the term we have. So for the second term, we take away 1 from 16, we get x to the 15. For the third term, we take away 1 for the third term, we take away 2 from 16, we get x to the 14, and so on and so on. Okay, so it's just really important to pay attention to where your x is in the expansion, and also what you're being asked to expand. Are you being asked to expand ascending or descending powers of the first term in your bracket or the second term in your bracket? Okay. If in doubt, write a few of them out. So we know we're going to have 2x to the 75 as our first term, then x to the 74 as our second term, so on and so on, right? So we can see the pattern here and write it out. I'd always encourage you to write it out like that, okay? So, let's have a look at this question now. So here we need to use our knowledge of individual terms as well as looking at and combining this with some other parts of algebra. I'm just going to cover the question. So, this question on the left-hand side, the first thing we want to do is find that x to the 4 term. So again, I'm going to set up my 3 boxes. I'm going to put the first one as 10 choose something, 1 to the power of something, qx as one whole term. And this tells me this would be to the power of 4, right, to the power of 4. So I know that this has to be 10 choose 4, and then this is going to be 1 choose 6. In reality, it doesn't matter because 1 to the power of any number is just 1. But because we want to be thorough with what we're doing and demonstrate the mathematical knowledge, we're going to include it in our working for now. So now, when we expand this and work this out, we're going to get 210 q to the 4 x to the 4. 210 q to the 4 x to the 4. And it tells me that the coefficient here is equal to 3,360. So we can say, therefore, 210 q to the 4 is equal to 3,360. And then it's a matter of solving this to find the value of q. So we've got q to the 4 is equal to 16. And this is a really key part here. If we go back to the question for just a second, we'll see this word written as values, value brackets values. And that's a really big hint. Whenever you see that usage of values, plural, it's a hint that we should most likely end up with more than one value. And the reason being, when we take the fourth root, we'll get a positive and negative answer here. Our answer can be positive or negative too. Both of those things raised to the power of 4 will give us 16 because we have an even power. Okay? We have an even power. So once you've had a go at that, let's have a go at this question on the left-hand side here. The question on the left-hand side. Again, I'll give you about a minute to go through and answer that question on the left, and then I'll go through and write up the answer. Okay, another about 20 seconds or so. Okay, so from here we should get that we've got our set up your boxes. So you've got 6 choose something, 4 to the power of something, ax. This is going to be cubed, right? It tells us this is going to be cubed here, so I don't need to worry about that. And then we've got 4 also cubed, because these two have to add up to give us 6. 6 choose 3, because it has to match with at least one of our powers. So when we expand this, we should get 1280 a cubed x cubed, and it tells us that this is equal to 160 x cubed. So from here we can just cross through the x cubes, you don't have to worry about them. We get 1280 a cubed is equal to 160. Rearranging, this will give us a cubed is 1/8, and therefore a is going to be cube root of 1/8. We should get 1/2. Okay. Again, we only have a positive value here. The question, you can see the difference in the question. Find the value singular of a, and here find the possible values plural of q. So you can see the hints that they're giving you in the question. It's really important to be aware of those little subtle hints that can give you information about what you need to answer. It's also important because here, if you didn't put the negative one and you only put the positive solution, you wouldn't get the mark, and that's really frustrating when you've done all the working and it's correctly done, but you've missed out a really subtle step there. So it's just important to understand those subtle differences. Okay. So this is a really common type of question, and actually they're really exam boards. I think they're really good questions because they test quite a large difference, so quite a large part of your mathematical knowledge and understanding. So we're just going to do a couple more of these. Okay. So the first part is to give this expansion. And in fact, I would say only give it up to the a squared terms. Okay, so I know the expansion says there, give the whole thing, but for us, we'll just do it up to the a squared term because that's what we need. All right, that's what we need. So first step, I'm going to let you some time just to go ahead and do that expansion up to the a squared term. So the a and a squared terms. So I'll make sure we've got those in there. So we're going to have our first one is going to be a to the 4. I might skip some steps here, so going straight to a to the 4. I'm not worried about coefficient because it's going to be 1. 2b to the 0 again 1. So I'm just going straight to a to the 4. Absolutely nothing wrong with doing that in the exam as well. And in fact, I probably recommend it. It just means it makes your working a bit neater as well. Then we're going to have 4, because I know 4 choose 1 is 4. 4a cubed times 2b plus 4 choose 2, which is going to be 6a squared times 2b also squared plus 4a times 2b cubed. And I'm not going to worry about the last term because it's not relevant for us for this particular question. So just tidying this up, we should get a to the 4 plus 8a cubed b plus 24a squared b squared plus 32ab cubed. And the only terms we're interested in are the a squared term and the a term. So it says, the question says the coefficients of a is 96. So we know that 32b cubed must equal 96. And the coefficient of a squared, so 24, 24b squared is equal to 216. Okay, so now then again, it's just a case of rearranging to find your values of b here. Rearranging to find your values of b here, and potentially we might end up with some quite nasty looking numbers here. In fact, here we should get, so b, if we rearrange this, we should get b squared is equal to 9. So b is equal to plus or minus 3. And that's what we're going to go with. Okay, we're going to go b plus or minus 3 from there. And then what I'll do is I'll reveal this second question on the right hand side, which I think is an exam question. Yeah, so we've got an exam question here. Let's go through and have a work through that one. I'll just give you some time and just rule this off to go through and complete that one, okay? So I'll give you about a minute to go through that question there, okay, on the right hand side. Again, this is the idea we're comparing coefficients here. To find these values. So let's go, I'll tell you what, let's go through this question. This is an exam question. So hopefully, Healy, this will clarify it. Let's go through this question on the right hand side. So it says find the first 4 terms in ascending powers of x. So let's go through and expand this to start off with, okay? So we should have, well, first term is just going to be 1 to the power of 10, which we're going to write as 1, plus 10 choose 1. I'm not going to include 1 to the power of anything because it's always just going to be 1. So I'm just going to do the choose function and the a to the x. So 10 choose 1, a to the x, plus 10 choose 2, a to the x. Let me just move this over a little bit so you can see this. 10 choose 2, a to the x squared, plus 10 choose 3, a to the x cubed. We've got our first 4 terms. Then we need to go through simplify. So this is going to be 1 plus 10a to the x plus 45 a squared x squared plus 120 a cubed x cubed. Okay, so we've got our expansion there. And then it says, given in this expansion, the coefficient of x cubed, so the coefficient of x cubed is double the coefficient of x squared, find the value of a. So the coefficient of x cubed is 120a cubed, and this is double, this value is double the coefficient of x squared. So 120a squared is equal to 2 times the coefficient of x squared, which is that. Okay, which is that. So now you can start to see, hopefully, that we've got an expression here that we then solve for a. So this is going to be 120a cubed is equal to 90a squared. Be very careful here again. We've got algebraic terms to a power. So we don't want to just divide through by a squared. Whenever we have algebraic terms, what we want to do is factorize this out. So firstly, what I'm going to do is divide through by 30 just to simplify down my coefficients. So we get this. And then I'm going to take the a squared to the left-hand side. So we get 4a cubed minus 3a squared equals 0. And then I'm going to factorize out a squared. So we're left with a squared and then 4a minus 3 equals 0. So therefore, from algebra, from lecture 1, we get two solutions. A is equal to 0 and a is equal to positive 3 over 4. And from here we go back to the question. It says in part A, where a is a non-zero constant. So we cannot have this solution, therefore a is 3/4. It's really important that we state both of those solutions, that we only choose the one that is relevant given the other parameters that we have. Okay? Given the other parameters that we have. I think hopefully that has clarified it, Healy. Is that what you meant? Move this back over. Does that question now? This question makes sense on the right hand side here. So this is an exam style question. It'll be a better idea of what you're sort of gonna be answering in an exam. Perfect, good stuff. Okay. So this is again going through and finding those individual terms, right, and using it. Sometimes you'll get similar ones like this that you'll then you might get two unknowns and you'll have to do simultaneous equations on them. But the general premise is like this: you find individual terms and then go through and solve them algebraically to work out any missing coefficients or values that you need to work out. Okay, so let's have a look at this one. So let's have a look at these two questions. Let's go through the question on the left to start off with. And then go through, do the expansion first. and then we'll have a look at that second bit about finding that value for x, or values plural for x, sorry. So just do the expansion first, and then I'll go through how to do the second bit as well. So another 30 seconds to go through that first expansion there. Okay. We should get 1 plus 6x. I'm just going straight to the answer here, so I'm not doing each individual step. I'm just going straight to the answer. But we should get 1 plus 6x plus 12x squared, 12x squared plus 8x cubed. Okay, so 1 plus 6x plus 12x squared plus 8x cubed. And the second bit says find the values of x for which 1 in brackets 1 plus 2x all cubed equals 1 plus 8x cubed. Well, what we need to do here is set this expansion we've just done, set that equal to the 1 plus 8x cubed. So the first step for part B is to write these two things equal to each other. And then we're going to solve to find a value for x. Okay, so then we're going to solve to find a value for x. So we've got the 1's will cancel on each side, 8x cubed will cancel on each side. So we're left with 6x plus 12x squared equals 0. And this is now quadratic. This is similar to the last question we just had. Again, really careful, we don't want to divide through by x. A really common thing would be to divide through by 6 and then follow that by dividing through by x. But this is, again, we go back to the question. It says values, plural. Find the values of x for which this is true. So we need both of these values. So let's divide through by 6 first, and we're going to get x plus 2x squared is equal to 0. And if we factor out the x, we get x, and then 1 plus 2x is equal to 0. So now we get our two solutions. Therefore, x equals 0 or x equals minus 1 over 2. And both of those are the solutions that we need. Okay, well, both of these are solutions that we need. Okay, so have a go now at this question on the right hand side there. Very, very similar, right? Very, very similar. Very, very similar there. And then we've got about 2 more slides on this particular topic about individual terms. So we'll finish those 2 slides and then we'll have a short break before we go on to the application stuff afterwards. So just start writing up answer to part A here. So that's the answer for part A up there. And then part B, again, have a look at what we've done on the left-hand side. Have a look at what we've done for the left-hand side. So the first thing was this step here about equating. And go through and solve on the right-hand side as well. And I'll write up the answers you should get there in just a second too. We should get 3 solutions for this question here. So, when we equate both of these things, we should be able to cancel out the 16 and the x to the 4, and we'll be left with 32x plus 24x squared plus 8x cubed is equal to 64x. Okay, and then we rearrange this and simplify. So rearrange, put all the terms on one side, divide through by 8, and we should end up with x cubed plus 3x squared minus 4x equals 0. So we've got a cubic here. We can factor out the x and then factorize the quadratic that we're left with. So we should end up with this as a fully factorized form. And then you can see we've got our 3 values of x. Therefore, x equals 0, x equals minus 4, or x equals positive 1. And again, you can see the hint in the question, find the values, plural, of x for which this is true. We've got our multiple values at the bottom there. Okay. So go through, just mark anything you need to, correct anything you need to, check your work in. But very similar questions, and again, this is just tying different bits that we've looked at already together. So this is, first bit is the binomial expansion that we looked at today. Then part B is essentially just looking at the algebra stuff we looked at previously about solving and factorizing quadratics and cubics. So, like I said, we've got 2 more slides and then we'll have a very short break. In fact, I say let's do it. It's been a long slog so far. So let's do this last slide and we'll have a break just after this one here. And then come back and finish off with the remaining slides. So this question on the left hand side, I'm gonna block this question on the right hand side for now. This question on the left hand side says find the term independent of x in this expansion. So what we see here is we've got 2x minus 3 over x. So we've got x and then as a numerator and x as a denominator. And what's the term independent of x? What that means is there will be a point in this expansion where we will just get a constant. The x's will cancel, the x on the numerator and the denominator will cancel, and we'll just have a value for x. Now, what you could do is go through and expand all of those terms until you hit that point, but really that's your last resort. We only want to go through and do all of that working and spend all of that time if we can't figure out any other way to do it. But what we understand is how we get this independent term of x. And that only happens when we have x on numerator and denominator with the same index. We can see we've got a power of 8 here. So there will be a point where if we draw our boxes out again, there will be a point where the powers on these 2 boxes here need to match. And with 8, that's simple because this is going to be 4 and 4. When we have 4 and 4, we're going to end up with x to the 4 as a denominator. And we're going to end up with x to the 4 as a numerator. So they will cancel out. We don't need to worry about them. This is what it means by independent of x. They will cancel out. And then we go through and fill in our choose function. This is going to be 8 choose 4. We also don't need to worry about this negative because we've got a positive index, so the negative will cancel as well. So now what we end up with is 8 choose 4 multiplied by 2 to the 4 multiplied by 3 to the 4. And then it's just a case of putting that into your calculator and working out what value you should get, which should be 90,720. Okay, so it's understanding. Like I said, we could expand all of that and we'll end up with this number in the middle. But actually, we want to look at, do we understand when we expand binomially what we end up with? What we end up with is this term independent of x when the powers are equal. When the powers are equal. Okay, so you can see that this is pretty much, the exam question is on the right hand side. The actual expansion is exactly the same. The only difference is the language, right? So it's just a comparison of the language here. We have the term independent of x in the left hand side, and on the right hand side it says a term which is a constant. So a number on its own is just a constant. Okay, so that's what this means, and that is just for comparison. That again, here the language used in an exam and used in practice is slightly different, but it means the same thing. Okay, so what we'll do is we'll have a short break. Let's say back for 12:20. Let's say back for 12:20. Okay, so a short break, get some water, get something to eat, and then back for 12:20. Okay, and I'll see you guys in a bit. we're going in just one more minute then. Give a chance to everyone to go get some water. Just 1 minute left. Okay, welcome back. Hope you guys had a chance to have a break, get something to drink, something to eat. I just wanted to go back very quickly to this question here on the left hand side, so this orange question. And I think Healy, you had a question about this one, and I went back and actually looked at this question again. And I think the question is written wrong because it says find the values of A and B, given that. And this information here, and we only went through and found the value of B. And I had a look at this question, and I think there was a typo here. I think where it says given that the coefficients, I think this should be the value. Okay, so it said the value of the A and A squared terms are 96 and 216 respectively. And this fundamentally changes how we now go about answering this question. So I'll use a chance second just to go back, find that question, cross out that word coefficients and write value. And then the first thing that we want to do is take each of those terms and equate them to those values. So we've got 32 AB cubed is equal to 96. And 24A squared B squared is equal to 216. Okay, and now what we're going to do is just simplify each of these individually. So in fact, I'm going to take this down here, just divide through by 32, so we get A cubed is equal to 1 so is equal to 3, I beg your pardon. And then this second one, let me change colour just so this is clear. The second one, we're going to get A squared B squared is equal to, I believe, 9. Right? And this is now simultaneous equations. So we've got 1 here and 2 here. This is going back to the work we did in week 1, my lecture 1 in algebra. The only difference is that rather than adding or subtracting, again, we want to try and get away from that elimination method. Whilst elimination is really helpful at GCSE and in some A-level cases, actually substitution is a much more powerful method. So what I'm going to do is I'm going to rearrange equation 1 and make A the subject. So we get A over 3B cubed. A over 3B cubed. Let's call this equation 3, and then I'm going to substitute equation 3 into equation 2. So we're going to get, rather than A squared, we're going to write 3 over B cubed all squared. And then B squared equals 9. So now, here we then expand this bracket. So we're going to get 9 over, this is going to be B to the 6 on the denominator, times B squared is equal to 9. Well, the 9s are just going to cancel. So that's going to cancel with that. So we get B squared over B to the 6, which is going to give us 1 over B to the 4 is equal to 1. And we scroll up so you can see this. And then if we rearrange, so we take reciprocals of both sides, we still get b to the 4 is equal to 1. And then taking the fourth root, we get b is equal to plus or minus 1. Therefore, b is equal to plus or minus 1. Then we're going to sub this back into equation 3. Ooh, if I can spell. Sub back into equation 3. So we have a is equal to 3 over, we had b cubed originally, well, that would either be 1 cubed or minus 1 cubed. So let's just put plus or minus 1 cubed. And therefore, a is also equal to plus or minus 3. Okay? So we can see a similar start between these two questions. They both involve having to take terms from our expansion and make them equal to other values or other terms, other expressions, and then using that to find the terms, either using some factorization and solving like we did with the blue question here, some quadratic knowledge and cubic knowledge, or some simultaneous equation knowledge like we've done with the purple and orange on the left hand side here. Okay, so hopefully I think Haley, that was where you initially said that that you weren't sure, and that was a mistake with the question, so don't worry, it wasn't you, it was definitely the question, but hopefully that's now clarified that as well. And we'll go on to, so we've got one more question to look at in terms of expansions of individual terms. So I'm just going to go back to this question here. Here, the way we found this term independent of x was we said, well, we have to have a numerator and denominator with the same powers of x. That principle is the same here. We need, when we expand this, a numerator and denominator with the same powers of x. However, we need to account for the fact that this is x squared here and not just x like we had last time. So last time we just had x and x to the power of 1. Now we've got x squared and then x to the 1 as the denominator. So this is 4 over x. This is 3, so this is minus 4 over x even. This is 3x squared. So we know that our indices up here must add up to 9. But we need to compensate for the fact that we've got 3x squared here somehow. So think about what our indices could be so that the overall index is equal. What I mean by overall index is the index of this multiplied by this. This multiplied by this must be equal to this. And they both must add up to 9. So I'll give you like 10 seconds, 15 seconds, see if you can figure that one out. So from here, this index is going to be multiplied by 2. This index is just x to the power of 1. They both have to add up to 9. So what we're saying is that this must be double this value in order to account for the fact that we've already got a squared here, right? This must be double this in order to account for the fact that this will be doubled when we take it inside this box here. So we now have a bit more information. This must be double this power, and they must still add up to 9. So you need two numbers that add up to 9, one of which is double the other one. So we're going to get on the right hand box, this is going to be to the power of 6. This is going to be cubed. And therefore we've got 9, choose 6 or 3. Again, it doesn't matter because it's symmetrical. But we'll always go with the second index normally. And now we can see, if we expand this, we will take 9 choose 6, which is going to give us, this is 84, multiplied by, I'm going to split this term up. So we've got 3 cubed. X squared cubed is going to give us x to the 6. Minus 4 to the 6. Again, we don't need to worry about the minus because we've got a positive index there. So that will disappear. So we've got 4 to the 6, which is going to give us 4096 over x to the 6. Let's just make this bracket. Over x to the 6, right? I'll just make this a bit neater. So now you can see our x terms will cancel. We now have a term that is independent of x, okay? So how I'll go through and just tidy that up, and I'll write up the full solution in just a second. Should get quite a large number for our final answer. So the x's here are going to cancel. And then it's just a matter of tidying this up and multiplying all of these numbers together. We should end up with 9,289,728 as our final value there. Okay? So, this is looking at individual terms. The key thing is this layout here of using these 3 boxes, right? Of understanding your choose term, then the first term of your bracket to a power, and the second term of your bracket to a power, and how we then go about filling in these values here, right? Understanding that our 2 indices must add up to give us the top of our choose function. That the bottom of our choose function must match one of the indices, and is generally this second one over here. And then we can combine them at a later stage, okay? But those are the key things to take away from that, okay? Right. Next bit is looking at some applications of this. So I'm going to go through, as always, I'm going to go through the example on the left-hand side, and then I'll give you some time to work through the example on the right-hand side. First step is to expand in ascending powers up to x cubed. So all I want you to do for now is go through, do that expansion, okay? So simplify it, do it in individual terms, and then go through and simplify it, and I'll write up the simplified version in just a second. We know it's going to start with 1. And then I'm just going to write up the answer. I'll give you about another half a minute or so to go through and work that one out. So our final answer, we should get 1 minus 20x plus 180x squared minus 960 x cubed plus dot dot dot. Okay, obviously the expansion carries on, but we've only been asked for these first few terms. Now the second part of the question is the new learning here. So this is using the expansion, finding an approximation for 0.98 to the power of 10. So we can see in this question we've got 2 items that are both to the power of 10. So what we then want to do is say, well, therefore 1 minus 2x, so our first item, must be equal to 0.98, right? Or we're letting this equal 0.98. We need a value for x, and this is how we're going to do it. So now it's just a matter of solving for x. So we're going to get minus 2x is equal to minus 0.02. The minuses are going to cancel. We divide through by minus 2, so we get x is equal to 0.01. And then when it says use your expansion to find an approximation, what we're doing is substituting that into this expansion that we've just found. And saying, therefore, 0.98 is approximately 1 minus 20 times 0.01 plus 180 times 0.01 squared, and so on and so on. Okay, what I would do is on your calculator, type in 0.01 and hit equals, and then when you do the working, all you need to do is type answer instead of 0.01 each time. So on your calculator, you'll have 1 minus 20 brackets answer plus 180 brackets answer squared minus 960 brackets answer cubed. And we should get an answer of 0.817 to 3 significant figures. Okay? And actually this is we should always go back and then check. So now what we want to do is type in 0.98 to the power of 10, and you'll see that to 3 significant figures we get the same value. If we type in 0.98 to the power of 10, we get 0.817072, and it carries on. But we know now that this approximation is correct, whether we've done it correctly, because we can see that. Okay, so let's have a go at this question on the right hand side now. Again, a very similar one. I'll give you a couple minutes to go through and have a go at doing that, and then I'll go through the answers as well. So in terms of the expansion, we should get, I'm going to write that answer up on the board just now. On the screen rather. I'm going to move this over so you can see it. So that's the expansion that we should get just there. Okay, so that's the expansion we should get just there. And then here again, we see we're trying to find 2.02 correct to 6 significant figures. Correct to 6 significant figures. So in fact, what I would do here is just type this very quickly into our calculator. And it's going to be 1000.133, and this is just for reference, right? This is just for reference. This is not a valid answer or anything like that. It's not going to count towards my working, but it's just for reference so that when I do get an answer, I know I'm along the right lines. So now we need to go through, find the value of x we need, and substitution. It's really important we show this substitution like we've done here in the orange. It's really important we show that substitution and that step there. So I'll give you just a little bit more time to go through and do that substitution there. So we should then have that. Well, 2.02 is equal to 2 plus x. Therefore, nice and easy, x is equal to 0.02. And then it's just a matter of saying, well, this is then going to be 1024 plus 5120 times 0.02 plus 11520 times 0.02 squared plus 15360 0.02 cubed. It's just about fitting it. Just going off the screen there, but you know what's wrong. And then it's just a matter of plugging this in. And as I said, easiest way to do is do 0.02 and hit equals. And then you can just plug in your answer there. When you're doing your calculator, you just have to hit the answer button rather than having to type out 0.02 each time. We should get 1131.130 ... And again, rounding that to 6 significant figures is asking us this time in the question. Let's just change these to approximation signs. So 6 significant figures, and we can see that this is to 6 significant figures identical to the actual value of 2.02 to the power of 10. Okay, so very similar. The first step's exactly what we've done before, just doing the expansion, and the second step is just working out value to substitute and doing that approximation. Okay, so this is more or less all of the pure side of binomial expansion done. Okay, this is the types of questions you'll be asked from the pure side. On the stats side, we have some probability stuff, and we're just going to cover that very, very briefly. Okay, very, very briefly. The key thing is that it is based on the number of different outcomes that occur, and to use a binomial, probabilities, there can only be 2 possible outcomes. For example, like heads or tails, or win or lose, right? Or like something and not something. So this apostrophe here, this prime, means not, right, in probability. So something or not something, right? 2 probability, 2 possible outcomes. So we've got this example here. And I'll give you a second just to go through and read that. So quite clearly, if we've got 5 counters and all 5 are red, well then the only combination we can have is red, 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 and red. Right? There's only one possible combination. For part B though, there'll be slightly more. You could have blue at the start and then red, 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 or blue in the second position and then reds around it, and so on and so on. And then C would get even more complicated. We would have blue and blue and then 3 reds. And then we could move the second blue along, then move the first blue along. And actually listing it is a very inefficient way of working out the different combinations when you get to large numbers that we're dealing with. So perfectly easy to go through and understand that actually there's only one outcome, not very time consuming. Even B, we could go through and list, we've done 2, we could list there's 3 more combinations there, not very time consuming. C, however, will start to take a bit more time. So what we want to understand is there a shortcut? If you're only interested in how the different combinations can work, is there a shortcut? And this is where we go back to this equation we had to work out values in Pascal's triangle, right? N factorial over r factorial times n minus r factorial. For example, in this particular case, let's say we want to look at B. What we could say is, well, there are 5 possible counters that we're taking. There are 5 counters that we're taking. Of those counters, one is going to be blue. And then what we're going to do is change the language to say, rather than red, we'll say not blue. So 1 is blue, and therefore 5 minus 1, 4 are not blue. And if we plug this into our calculator, so if we plug this into our calculator, you should see that we end up with 5. Which is what we said, we've got 5. If we carried on listing as that, we would get 5 different combinations. So now I want you to think about, without listing out, how many different combinations could we get for part C here? How many different combinations could we get for part C here? We've still got 5 counters that we're taking, but what is our denominator this time going to look like? Have a think about what our denominator is going to look like this time. And have a go at working it out as well once you've done that. So again, if we go back to part B, we had at the top here, we had 5 possible counters. 1 was, let's call it success. So 1 was a success, and then 5 minus 1 would be not successful. We can use the same idea here. 2 successful, so blue counters, let's call blue counters successful. We have 2 possible successful outcomes, and therefore 3 unsuccessful outcomes. If we plug this in, we'll get 10. And this makes sense. If you were to list out the possible combinations between 2 blue and 3 red counters, you would get 10 possible combinations, right? And this is now we can start to see that link between binomial values from Pascal's triangle and probability, and we can extend it as well. So let's just go through this question on the left hand side first. So I'll give you a second just to read through the question. So what's going to happen here is we've got 11 possible selections, right? We're picking out of a total of 11. So our numerator is going to be 11 factorial. Of those 11, we only want 3. We only want 3. Now, only 3 of these dogs are going to be successful. So again, we're using that measure of success. So out of 11, only 3 of these dogs are going to be successful. Which means there will be 8 unsuccessful dogs. So the number of different combinations that will result in 3 successful and 8 unsuccessful dogs will be given by this calculation here, 11 factorial over 3 factorial times 8 factorial. And we see there are 165 different combinations where out of the 11 total competitors, 3 will be successful and 8 will be unsuccessful. Okay, so this is what this this value, this factorial notation here is describing, right? How many different combinations of these things can we get? So let's have a go at this question. I'll give you some time to go have a go at this question on the right hand side. About another, let's say another 20 or so seconds, just to have a go through. Okay, so again, we are flipping this coin 8 times. 8 times. So there are 8 possible opportunities for success that we have. Again, if you're calling success landing on heads. So 8 possible opportunities for success, but out of them, only 5, we're looking for how many will give us only 5 successful attempts. Well, if there's 5 successful, there must also be 3 unsuccessful attempts. And that means there are 56 different ways that out of 8 flips of a coin will end up with getting heads 5 times. We could even switch this round and we still get the same answer, right? If we were to define and work out getting exactly 5 tails, and we turn that into 3 factorial times 5 factorial, we still get 56. This is why binomial only works for 2 outcomes, successful and not successful, because of that idea of symmetry, because of the idea if we swap it around, those values don't change. Okay. Now we're going to look at we've gone from working out possible different options to looking at, well, what does that actually mean and what is the probability that we get. So let's have a look at this question on the left hand side to start off with. So I'll give you a second just to read through that. So if we just get rid of parts B and C, part A is essentially a GCSE question, right? This is asking what's the probability of getting 6 and 6 and 6 and 6 5 times. Remember, we had the AND rule. We were just multiplying. We were just multiplying the probabilities together. So we can shortcut that and say, well, the probability of getting 1 6 is 1/6. And we want it to get it 5 times. So this can be 1/6 to the power of 5. So the probability of getting 6 5 times in a row is 1 out of 7,776. We had and then we've got B. So what's the probability of getting no 6s? So not getting any 6s at all. Well, the probability of not getting no 6s on one go is 5/6. Probability of not getting it in 5 goes would be 5/6 to the power of 5, which is going to give us 3,125 over 7,776. But this is GCSE style kind of level, the AND rule that we should hopefully have come across at GCSE. The last bit here, part C though, that's a bit more tricky. What's the probability of getting exactly 3 6s? Well, the probability of getting a 6 is 1/6, but again, we only want that 3 times, which means there will be 2 occasions. Sorry. 2 occasions on which we don't get 6. Right, if we're rolling it 5 times, there'll be 3 occasions where we do get 6 and 2 occasions where we don't get 6. But we also need to know the number of possible ways that this can occur, the number of possible ways we could get 3 sixes and 2 non-sixes, because at the moment we're just finding it for any single row. But the total probability across 5 rows is going to be this multiplied by the number of possible ways that this could occur. And here we get that choose function notation in again. This is going to be 5 choose 2. So we've got the first bit. This is the number of ways in which we can get this outcome of 3 sixes and 2 non-sixes, multiplied by the probability of each of those individual events. So if we plug this now into our calculator, and let's just work that out, we're going to get 125 over 3,888. So this formula that you see in the top right over here is describing exactly that. It's saying what is the probability of some event occurring a number of times. So 6 occurring exactly 3 times. Well, that is 5 choose 3. P to the 3, 1 minus P to the remainder. Again, we've done 2 here. It doesn't matter. N 5 choose 3, 5 choose 2 will give us the same value. Okay. So this is where we see we've got n choose x. If I write underneath here, the probability to the power of, in this case we've done it as n minus x, and 1 minus the probability to the power of x. Okay. This is just keeping that consistency of having the second thing match the power of the second item match our choose function. Okay, so now let's have a go at this question on the right hand side here. I'll give you again about a minute to go through that. And I think we've got about 2 slides left after this, so not much more left after this. Well done for sticking with it, and then we'll round it up there. So in case you're not sure, I'm just going to help start you off. Again, think about what we want. So you want to know the probability that what we're selecting is blue. So our success is blue. This is going to be 7/10 here, which means this is going to have to be 3/10 over here. We want 5 successful opportunities. If we're choosing them 6 times, that will mean 1 unsuccessful. And then we're going to get, this is going to have to be 6 choose 1 over here as well. And then it's just a matter of typing this into our calculator. Our final answer should therefore be 0.303 to 3 significant figures. Okay, so you can see it's always how many different combinations of this are there, multiplied by the probabilities of success and the number of to the power of the number of times we want success, multiplied by the probability of failure to the power of the number of times that there will be failure. So it's always that pattern, always that pattern. Okay, so there are some more questions on this screen here to have a go at as well. So let's go through question on the left hand side. Question A. I'll give you some time to go through question A, and then question B. If you feel confident, have a go at it. This is the penultimate slide, so we've only got one art left after this. So part B, if you're confident, have a go at it. The language is slightly different in part B, and that's what I'm going to touch on when I explain it. But I'll give you some time just to have a go through part A yourself for now, and I'll write up the answer in just a moment. So again, think about how many total options are there and how many options for success are there. What is the probability of success and how many times do we want success? What's the probability of failure? And how many times do we end up with probability of, with that failure occurring? So we should have that there are 30 possible options. The probability of success is 0.12, and this is going to occur 3 times. Let's make that clear, 3 times, which therefore means the probability of failure is 0.88, and this will occur 27 times. Which means that this is going to be 30, choose 27 down here, or choose 3, again, it doesn't matter. And our final answer is therefore going to be is 0.222 to 3 significant figures. Okay. Now part B then, it says at least one person, I should say is left-handed rather than in. At least one person is left-handed. Well, this means we could have one person left-handed, two people. I think there might be some issues here. Okay, now I think we're back. My apologies. I think we're back now. So, as far as I know, we're good. So I'm going to carry on. So part B, it says, at least one person left-handed. We're going to think about it slightly differently and say, actually, well, if at least one person is left-handed, the only probability, the only outcome we don't want is that everyone is right-handed. That's the only thing we don't want. So we're going to write this as, well, we want this as 1. That's the total probability is always 1. 1 minus the probability that every single person is right-handed. And that is simply 0.88 to the power of 30. Right? So this is the total probability here, total probability, minus the probability that every single person is right-handed. So this is, don't have to worry about any binomial expansions here. This is much more straightforward than that. We should end up with 0.978 to 3 significant figures. Okay? So, we don't have to worry about outcomes because, like we said, like we said when we were listing the outcomes at the very start of this bit, there's only one way we can get 30 right-handed people, and that's if everyone is right-handed. Only one combination. So we don't need to worry about looking at the number of combinations we have and the probability of failure, because there are no options for failure. This is only 30 options of success. So let's have a go at this question on the right hand side here then. I'll give you about 2 or 3 minutes to work through that, and then I'll put up the answers as always in a second. And again, if you're not sure, look back to the question on the left hand side, think about what we've done there, and then have a go at the question on the right hand side again. Very similar questions here. So I'm just going to start filling in question A. So all I've done so far is take the information from the question, right? There are 10 different outcomes that we are looking at. Of those, the probability of it being 40, which is what we're looking for, so the probability of it being 40 is 0.05, and we're trying to figure out, well, if 2 of them are 40, and therefore the probability of it being not 40 is 0.95. So now I can go through and start filling in some other information. 0.95 to the power of 10, right? 1 minus the probability that all are working correctly to the power of how many there are. We should get an answer of 0.401 again to 3SF. Okay. And in general, unless the question specifically asks you, you can leave your answers in the format it's given on your calculator. So if your answer is given as a fraction on the calculator, I would always give it as a fraction. If it's given as a decimal, then I would give it as a decimal, round it to an appropriate value. Okay, but there's no need to put it into a specific format unless the question specifically says. Okay, all right. One last question then. So we've got an old exam question here, and then this is the last bit. We'll finish off after this. Well done for making it all the way through. Week 3 almost in the bag. So I'm going to give you again a couple minutes to have a look through this question and go through it, and then I will put up a solution in just a moment. Josh, what school are you coming from as well? Just curious. Okay, so again, set up your working as we need to. So we've got the 3 parts to it: the number of different attempts, probability of success, probability of failure. Oh, good stuff, Josh. Good stuff. Good stuff. So we are going to have, we want out of 9 attempts, 6 successful attempts. And in fact, they've actually quite helpfully used that language of success in this question. So we've got out of 9, we want 6 successful attempts. The probability of success is 2/3, and this is going to be therefore to the power of 6. Therefore, the probability of failure is 1/3. This is going to be therefore cubed because the two powers here must add to give us 9. And again, therefore, this is a matter of plugging this into your calculator to get your solution. And we should get an answer of 1,792 over 6,561. Okay? And that's it, that's a wrap. Okay, excellent stuff. Well done for signing in for week 3. I hope you found it helpful as always. Any feedback is more than welcome. Go back and watch these videos, use them for revision, use the resources that are in the comments. As always, share, spread the word, let other people know, let your friends know. Follow us on Twitter, follow us on Facebook. But otherwise, enjoy the rest of your week, and I'll see you next week at 11. Thank you very much, Josh. We appreciate your kind words. And stay safe and take care. Bye, guys. You're welcome, Healy. See you later.